Well, it has been almost 2 months since we have reviewed a 3D printer on this channel, and that is not due to there not being 3D printers out there, because I feel like every single week there's multiple machines announced, but really it is because I've been wanting to make some different videos for you guys. So since I started making videos many years ago, this whole entire time I've been putting together a list of these ideas that I have for different videos or projects or how-tos or different materials I want to test out. But it seemed like the 3D printer reviews were almost getting in the way a little bit. And as much as I do really enjoy them, I wanted to deviate a little bit from that to be able to offer these types of videos that I've been doing for you guys lately, which you all really seem to be enjoying. Another thing that's been going on as well is that a lot of the 3D printers coming out are pretty much copy and paste of other printers already existing. And this is especially true in kind of the hobby realm or budget realm of 3D printers. And some of them are sure creating new things or adding little additional features, but a lot of them just seem like the same printer over and over again, which has been another reason for why I've kind of taken a step back from doing a lot of reviews for a bit now. Well, with that being said, we are going to be doing another 3D printer review in this video. This time it is the $300 Ortur Obsidian printer. The features that I really liked about this low-cost 3D printer was that it had auto bed leveling, it was direct drive featuring a clone BMG extruder, so it has dual gears, which will really help prevent filament slipping. And I also really liked the look of it. I know that aesthetic might not mean very much, but the fact that it had all kind of black and red accents, and it even had a red PTFE guide tube to match that, I really liked that and thought that this machine, just combined with those specs that I mentioned, seemed pretty awesome. So over the past month, I've put a ton of filament through the Ortur Obsidian printer. And in today's video, we are going to talk about the printer specs. We're going to talk about what my initial setup and calibration process looked like. We're going to, of course, do some 3D printing. And then finally, I will go over my list of some of the things I liked and some of the things that I did not like so much about this machine. I hope you guys are excited. And without further ado, let's get right into today's video. So in that order, let's kick things off first with the specs of the Ortur Obsidian. Like so many budget 3D printers we see, the frame is made of aluminum extrusions and the base is made out of like a sheet metal. It has a build volume of 250 by 250 by 300 millimeters. It has dual lead screws as well as a belt that connects the two to make sure that they stay even once you set them, and it even has anti-backlash nuts. As I mentioned previously, it is also a direct drive system using a clone BMG that feeds into a clone E3D Lite 6. This does mean that it is not an all-metal hot end, and the PTFE runs all the way through to the nozzle, so you will not want to take it above roughly 250 Celsius. However, because it's using kind of a clone E3D Lite 6, it should be very easy to drop in an authentic all-metal E3D V6 hot end should you want to be able to print with some higher temp materials. The bed uses a standard aluminum style heated bed, but the sheet on top of it is kind of interesting. It's a clear sheet that I originally thought was PEI, but after looking at it and printing with it now for the last month, I don't believe that it is. It's not listed as a PEI sheet, it just says clear sheet. But whatever it is, it did work really well with all the filaments that I tested on this printer. For the bed leveling, the Ortur Obsidian uses an inductive probe, and it has a filament runout sensor as well as power loss recovery. The Ortur Obsidian does have belt tensioners on both the X and the Y axis, which is kind of becoming more common, but not all machines have that, so it's really nice to see to make sure you've got the correct tension on your belts. And it uses ribbon cable similar to the artillery machines for all of its cable routing. You will interface with the printer using the touchscreen on the front that is fairly bright and responsive. And as far as connectivity goes, you have the option to print over micro SD card, or of course you can print over USB and even hook it up to something like Octoprint. For the firmware, this machine is running a modified version of Marlin firmware. Now that covers everything on the outside of the machine, but for those of you that want to see the inside of the machine, let's go over that very quickly and pop the hood or take the bottom off of this machine. Inside the printer, you will find a Ortur board, which is a 32-bit board that is using TMC 2208 stepper motor drivers, which is definitely nice to see. There's also a power supply module, which is 24 volts, meaning that the bed will be able to heat up nice and quickly. There's even a relay below, which is not something I've seen too much in 3D printers, that can be used to kill the power to the printer. So the way this machine is set up by default is when a print is completed and the hot end and the bed cools down, it'll actually turn the power off on the machine, which you can quickly turn back on using the power button on the front of the machine. overall everything was routed nicely and I was happy with the included electronics. Okay, so now that we've gone over the specs, what does setup look like? So everything came packaged really nicely. There is a one sheet of instructions that came included with this printer, but I will say they were definitely not the best set of instructions, and multiple times it had me looking at things or backtracking to ensure that I was putting things together correctly. I did find out later on that on the included USB or SD card that there is a higher resolution version of that PDF, as well as some included video guides, but they're still not great, and I definitely think that they can use some improvement to ensure that you are not assembling this incorrectly and to help just speed up that initial process. All in all, I would say for most, it's likely going to take roughly about an hour to go from out of the box to ready to turn on. So once I had completed assembly, I turned on the printer and went to home everything, which is where I ran into my first issue. When it was homing, one of the sides would home fine, but the other motor would kind of lag behind and then slowly lock up as the two Z motors got too far away from each other. After looking at things a little bit further, I think it was more so on my end when it came to assembly. What I didn't do, I don't believe, was tighten all of the aluminum extrusions at the same time. I think that because I was in a rush, kind of torqued one of the sides and then tightened the other side after, which ended up slightly skewing the aluminum. So all I had to do was go ahead and loosen the main bolts for the machine and then just tighten them all at the same time, and that seemed to fix that initial issue. Once that was completed and the printer was homed, I went ahead and manually leveled the four corners of the bed. There is manual leveling screws, although it does have auto bed leveling. It's recommended to do a quick manual level just so that way the bed's not crazy out of whack or crazy tweaked, which it wasn't, but I did just do a quick bed leveling. And then I went to run the automatic bed leveling sequence, which is when I sort of found something that was strange to me. So most machines that I've used with the auto bed leveling will have you set your Z offset by slowly jogging the head up or down. On this printer, you set the Z, but you pretty much have to guess that value. Once you run your first print, you can then baby step it to correct it, but it is a bit strange. I recommend setting this value a bit higher so that you can lower it when the print starts versus too low and having it scrape your bed. So once you do run that first print and you baby step the nozzle to the correct height, it did seem to work really well. The setting stuck for all of the prints I did after that, and it does save that to EEPROM, but it does seem a bit backwards to me, the fact that you can't just jog the nozzle to the correct height before you start your first print. And this is something that should easily be able to be fixed via firmware update. I just really hope that it's something that they do end up doing. Now that the printer was leveled and working correctly, I went ahead and loaded a spool of PLA, plugged in the micro SD card, and hit print on a test file. The print started laying down fine, and then about 30 minutes later, I came back to see that the print had failed. And I then went ahead and started a print again and noticed that it failed again. And so what I was seeing was happening was that the power was actually cutting out. In the first half an hour of running a print, it would basically just do a quick power reset, like where it would flash and then boot back on. And so clearly there was something wrong. I took a look at all the electronics and everything seemed to be working okay, so I wasn't exactly sure what was causing this, but it definitely seemed like it was power related. So I reached out to the manufacturer, who confirmed to me that they did believe it was one of the power regulating modules on the underside of the bed, and they went ahead and sent out a new one, which arrived about roughly 1 to 2 weeks later. So when I got that new board in, I installed it and held my fingers crossed that this would be the part that I needed and that would actually fix what was going on, and I am happy to announce that that did solve the problem. So now that we've got everything functioning correctly, which again, up to this point, really the only thing was this power module. The leveling is just kind of strange, but you can easily get around that. And the skewed Z-axis was actually due to me and not due to a defect in the printer. I was ready to do some printing, and I knew that I wanted to do a video on how much could you print with a full spool of PLA, and I figured what better way to test this machine than to run an entire kilogram from start to finish through this printer. So that is exactly what I did. In total, with that spool of filament, I ran about 16 prints through this machine. That in total added up to roughly 80 hours of print time, and I've got to say that I was really impressed. Out of all of those 16 prints, they turned out perfect with the exception of one failure. One of the parts had a pretty gnarly layer shift, which I am not sure what caused it. I wasn't around. I just came and saw the finished part that was about 70% up, not looking correct, but everything else, including a massive birdhouse that took somewhere between 2 to 3 days, turned out perfect, and I was really happy with the results that I was getting off of this machine as far as the PLA print quality goes. If you do want to see some additional footage on those parts aside from what you see in this video, last week's video was where I talk about what you can print with a full spool of PLA, and every single print in that video is a print that came off of this machine. So that will give you a better idea of what those parts look like on top of the footage in this actual video. So I don't always print with other filaments when doing filament reviews, but in this instance, I did want to try at least 2 other filaments. So I loaded up some red PET and I found a really awesome low poly Fox over on Thingiverse that I thought would look really good in this color. I went ahead and sliced this up in Cura, actually using the same profile I used for my Ender 3 with direct drive, and I hit print. And the part turned out great. It looked really nice, and I definitely would say if you want to do at least a bit of PET printing, you will have no issues with this setup printing in PET filament. Now the last filament, which I've gotten much more accustomed to using as of the last few months, is TPU or flexible filament. Since this machine has a direct drive, and especially because it's like a BMG style clone, I figured that it would be able to at least handle some flexibles. They do advertise on their product page that it can print with flexibles, so I figured let's give it a run for its money. So I loaded up some Matter Hackers translucent blue build series TPU that I had laying around, and I sliced the file in Cura. I turned off retraction, and I had this printing at 40 millimeters a second, which in all honesty is quicker than I would normally print flexible filament on just about any other machine that I have. But I figured let's just give it a go. I watched the first 5 or 6 layers lay down and they looked great, so I went ahead and walked away and came back the next day, and also was hoping that I would not have either a spaghetti mess or a damaged printer or something like that, because flexible filament is always a little bit of a wild card in my experience. But sure enough, I was left with a really, really good looking print. I was actually blown away, because even with flexibles, I've had plenty of times where I print and the first few layers look really good. Halfway through the print, a quarter through the print, it actually starts to clog or under extrude. But no, from start to finish, this print turned out really nicely. And it just goes to show that you can definitely print flexible filament on this. I even think that you could print something softer, like possibly Ninja Flex at 85A shore hardness. But if you're gonna be doing that, I think that it would take certainly some slower print speeds and a little bit of tweaking to find the best settings to print with that material on this machine. So after about 20 prints and a month of testing, the Ortur Obsidian definitely gets my thumbs up for its print quality as well as its ability to consistently lay down a bead of filament. So we've covered a lot about this machine, and I've talked about, its good print quality and the things that I really liked about it, but the few things that I would like to see improved are, first and foremost, QC. I mentioned that I had to replace a board on my printer out of the box, which definitely is not a positive thing. I also happened to catch over on Neri's channel that he received one of these machines and his had a bad PSU or power supply out of the box that he had to replace. So I understand that things can get damaged in shipping, but this is something that needs to be addressed on a manufacturer's level, and I really hope that they can ensure that moving forward, their machines are working out of the box and don't require day one parts to be swapped out. Next, which I've covered multiple times already, is the bed leveling. If they could just tweak that a little bit to that way you can set the Z offset by actually using a piece of paper and physically setting it versus just guessing a number or trying to measure the distance, that would be awesome, which is just a super easy update in firmware. I'm going to definitely send them off a message in hopes that they will see if they can include that. And the final thing is something that's quite small, but was definitely an annoyance, and that is the layer cooling fan. The layer cooling fan on this machine uses a blower fan, and it is without a doubt the loudest cooling fan I've used on a 3D printer in as long as I can remember. I don't know whether mine just had a bad bearing or whether the bearings for this fan are cheap. Again, you could definitely swap it out, but when I had this thing printing and the layer cooling fan was on, which it was on for just about everything, especially that whole kilogram of PLA, you could hear the fan revving from the next room over, which to me is just absurd. So again, couple dollar part, something you could swap out, but I will also be letting them know, hey, I don't know if this is just my machine or whether it's, the fans you guys use for these in general, but it is quite a loud layer cooling fan. With that being said, for $300, I think there is certainly a lot more good than bad that comes with this 3D printer. And if you're someone that's either looking to get your first 3D printer or maybe has an Ender 3 but has been looking at adding a more budget-friendly direct drive machine to your lineup, then this is certainly a machine that's at least worth taking a look at, because the specs that this machine offers, in my opinion, are quite impressive when compared to a lot of other similar entry-level machines out there on the market. And that has been my review of the Ortur Obsidian 3D printer. If you have any questions on things I didn't cover in this video, please let me know in the comments down below. If I don't have the answer, I will find out from the manufacturer what the answer to your questions are. Don't forget to like and subscribe for more great videos. I make a video every single Saturday, so there is always fresh content coming your ways. I really appreciate all the support that you guys have been sending my way. It's been absolutely incredible, and the channel has been growing substantially. If you do want to support the channel furthermore, I'll place links down below in the description to my Patreon, where there are some pretty awesome rewards, and a huge thank you to all of my current Patreon supporters. You guys rock, and I really appreciate you guys allowing me to spend more time doing what I love, which is making content for you guys. On that note, this has been Deanna from ModBot, and I look forward to seeing you guys in my next video. Peace, guys.